Hey, welcome to C Programming Tutorials. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. In today's tutorial, we are going to learn about how to pass pointers to structures to a function. So, or in other words, how to pass the structure pointers to a function. In the previous tutorial, we learned that this is how you actually pass the structure itself to a function. So we wrote a small program that computes the area of a rectangle, and we represented a rectangle using this structure by specifying length and width as the members of this structure, and then we wrote a function called area which takes the rectangle by value, and then it computes the area by multiplying length and width and then returning back the result of this product. And then in our main function we declared a variable called rect1, which is of type struct rectangle. So rect1 has two members, length and width, and we set the length to 10, we set the width to 5, and then we called this area function by passing rect1 as value. So essentially what we did was when we had this rect1 here, and we basically we set its value of length to 10 and value of width to 5, and then when we call area, what happened was it ended up in it ended up in making a copy of this structure, this whole structure, and put it into what is the dummy parameter of this function, rect. So it copied the values of rect1, which is 10 and 5, into this structure, and we computed the the area, and then returned the area back. This is passing the structure with value. In this tutorial, we are going to learn how to pass it as a pointer. So obviously, and we have done this before with the, arrays and stuff. So obviously, if you want to pass it as pointer, we have to declare it as pointer here. Okay. So this is how we declare it as a pointer. So now rect is a pointer. So since rect is a pointer, we learned that in one of our previous tutorials, we learned that if it is a pointer, to access the members of a structure pointed to by a pointer, you don't use dot, you use this operator here, the arrow operator, dash and greater than sign. So you use this to basically access the member elements here, the length and the width. Okay, and we compute the results just the same way and return the result back. So this function actually, instead of taking the structure itself, it just takes the pointer to the structure. So how are we going to call? How the call is going to be different? Any different? The answer is yes, because before we were passing the entire structure to it, the main structure rect1, which is defined as the struct rectangle, we need to actually pass the address here, because we have to match the types. So type of this parameter is actually struct rectangle pointer. So it's a pointer, it needs an address here. So what we have to do is we have to pass an address here. So how to get the address of rect1? Of course, the ampersand operator, okay, the reference operator. So we basically get the address of rect1 and we pass it into this function as parameter, and the function does everything the same way, and it returns back the result, and we get the result back. So if you try to visualize it, instead of let me see. Let's see if I can choose this whole thing and then do a Control X. So yes, back to pen, and what we are doing here is actually we have a pointer called rect now, and we have the original rect1 in our main program here, rect1, which has the value of 10 and 5, and then as we are passing, what we are doing is we are taking the address of rect1 and putting it into rect. So as soon as we do that, we put the address of rect1 into rect. What happens is rect starts pointing to rect1. And then when we access rect length, we get 10, and when we access rect width, we get 5, and we multiply them together and we get 50, and that's the value that we return back, and it gets assigned to rect1 area. So let's run this program and see what happens. So as you can see, when this program runs, the same thing happened, the same result as before, 50, which is the product of 5 and 10. That's what we get as the area. So this is perfectly this is another way of returning of passing the structures to a function. Usually there are basically essentially two ways. So one is to pass it by value, the other is to pass as a pointer. Now what is the preferred way? A lot of time people prefer to actually use this method. And the reason is that when you use this has a fixed size of pointer. That's it. So here all you are passing is the pointer. Before, we passed the entire structure. Now our structure is very small. It has only 2 elements. Now this structure could be very huge. Remember, a structure can have structures in it also. So we define this struct rectangle. We could define some other structure, and we could have variables with this name, with this type, struct rectangle inside it. And similarly, inside the struct rectangle, we could have other structures. So in general, structures can have structures inside it, and then those structures can have structures inside it, and so on. So this could be really big. There could be an array, a big array inside it also. So these could be really big structures. And when you pass it as value, what it means is that it makes a full copy of it in here, and that actually occupies lots of space on stack. And that's not good. But if you declare it as a pointer, all you have to do is to pass the address. That's how this function can access all the elements inside it, and you could use it just as good. So all you have to do is to just pass the address into this function, and that's it, you are done. So this, a lot of time, because of this, it's a preferred way. Now one thing is that if you made any changes to length here, remember this, it will change the value of length in here also, of this variable also. Why? Because essentially this rect is pointing to where this guy is pointing, like in this picture. So if you change rect, if you say rect length is equal to 20 in here, okay, that will change the value of rect1 dot length to 20. If you print it after that, after making this function call, it will print 20 here. So that's a kind of a drawback. So if you accidentally start making changes here, then it's going to change the value of the caller variable in here. So you have to be careful if you define it as pointer here. There is one way of actually getting the help from the compiler, saying that, okay, I will never change it, okay, change any of its members, by declaring a constant here, const, which we haven't learned, so I'm not going to talk about it. I'm just mentioning it. So there is a way of basically preventing this from happening, but as far as our knowledge is concerned at this time, this is a drawback here. Now this could be a good thing also. What if, for a moment, think of it that there is an area declared here also. Now you could actually, what you could do is you could say rect area. So that way you are actually computing area right then and there, and we could basically make it void, remove this and remove this. So all we are doing is basically compute the area and not even put in here, and change this to actually print rect1 dot area. And area would be computed by this function when it will be called like this. So I'm going to stop here. This concludes this tutorial. We'll continue with the other tutorials. Thank you so much.